Hey everyone. In today's video, we're going to take a look at how to find the x and y intercepts of a linear function. Okay, so the first thing we're going to look at here is to find the x-intercept of a function. So what we have to do is substitute 0 in for y and solve for our x. Now we know that any x-intercept on the graph is always going to have this form where your y value is going to be 0. That is the reason why we're plugging in a 0 in for y, and we are going to solve for our x value. Okay, so let's go ahead and take a look at this. Okay, so we have 3x plus 4 times 0 equals 24. That gives us 3x equals 24. And then divide by 3 on both sides, and I get x equals 8. All right, and we know that that would mean that our actual coordinate of our x-intercept would be 8, 0. All right, so that's the general way to solve for the x-intercept. Now let's take a look at how to get the y-intercept. Okay, so common sense, kind of same equation. If we're looking for the y-intercept, we know that it's going to be the opposite, meaning that our x value, whenever it's a y-intercept, is going to be 0, and we are going to be looking for our y value. Okay, so same idea, just we're going to plug in 0 for x this time instead of y, and we're going to solve for y. 3 times 0, that cancels out. 4y equals 24. And then divide both sides by 4, and we get y equals 6. Okay, again, put it in the coordinate. It's going to be 0, 6. Okay, now the example I did was in standard form, but this will work for any linear equation. This will actually work for any kind of function. It's the same idea. If you're looking for the x value of any function, you're plugging in 0 for y. If you're looking for the y-intercept of any function, you are plugging in 0 for x. Okay, so whether this is standard form, slope-intercept form, point-slope form, it could be a different kind of function, which we'll talk about in the future videos. This same property of looking for the x and y intercept can be used for pretty much any kind of function.